Okay, so now that we've looked at how to go about defining a function and also why we use functions in the first place, let's look at what we want to do in program 6. So in program 6, we're going to write three different functions. We'll write a function to get a positive integer value from the user and return that value. We'll write a function that calculates the area of a circle based on a radius, and then we'll write another function to calculate the volume of a sphere based on the radius. All right, so let's go ahead and go over to Eclipse and get started on this program. Okay, so I've already created the Program 6 project folder and also the Program 6 source file. So if you need to create the project folder and the source file, and go ahead and pause the video at this time and create those. All right, so now since we have the folder in the source file and we've also copied in what we want to do in terms of our functions, and I've also done our pound includes and our using namespace standard. So these are the normal include files that we have. So let's go ahead and write the first function. So the first function is to get a positive integer value from the user and return that value. So the return value is going to be an int. The name of this function really could be anything that you want it to be, but it should be indicative of what the function does. So I'm going to call it get pos int for get positive integer. And I'm going to specify that this does have a formal parameter. We could have an empty formal parameter list here, but I'm going to allow the user to specify a string. So they can pass in some string. Maybe they pass in the string of enter a positive integer for the radius of a circle, or enter in a positive integer for the length of a square, or something like that. Who knows? So they can specify that. Come down a line, open brace, close brace, and then we'll need to do what? We need to get an integer from them. So we'll specify or declare an integer, say int num, assign it to 0. And then we'll do cout, and then say, well, we'll just use our message, right? So whatever message that was supplied, we'll use that. And then we'll just use endl. So here, our formal parameter message, this was just an arbitrary name. It's just an abbreviation for message. We could have named it X for that matter. It doesn't matter. But this thing here, whatever was passed in, is going to be substituted in here as well. So next line is cin, and then we'll use the extraction operator and store whatever they type in on the keyboard to num. All right, so what we have here would be perfectly fine if they inputted a positive integer. But it may be the case that they don't enter in a positive integer, and we would like to ask them to input the number again. So let's set up a do while. So we'll say do these statements that we just wrote or typed. While what? While the number is less than or equal to 0. So this is ensuring that we are in fact getting a positive integer value. So make sure the semicolon is here at the end. So now once we have a positive integer value, we can just simply return that number, that integer value to the user. So in our functions, if we have a function that's supposed to return an integer value, then we better have a return statement in that function that's returning the appropriate type, and num is of type int. Okay, so that's our get positive integer function. Let's go ahead and write our area of circle function. So it's going to return a double. We could say it returns a float or an int or something like that, but I'll specify a double since we could end up with a fractional part. And then we'll say that the name of this is simply area of circle. And what we'll pass into this function is just simply the radius. So anytime we specify a formal parameter, we get to specify both a type and a name. So int and r, that's the type of the name. Okay, so now that we have the function header, we'll just simply have a single expression, so return. And then our expression would just be pi r squared, since that's the area of a circle. And we can approximate pi by 3.14159 times. And the way we go about specifying r squared, you may think that you can do r caret 2, but that doesn't work. Remember that the little caret operator stands for the exclusive OR operation. So we cannot use that. We have to use what's called the pow function for the power function. And it takes two arguments. The first argument is the base, which would be r, and the second is the exponent. So what are you raising the base to? The PAL function, though, is not part of IOStream and it's not part of string, so we need to do another pound include. So this is again part of the C++ standard library, and we want to include the header file for CMath. Okay, so make sure you do the pound include for CMath. Otherwise, whenever we compile this, we'll get a complaint. It looks like the compiler is already complaining. Well, not the compiler, but the code analyzer built into Eclipse is complaining about something. So if you hover your mouse over it, it'll probably say PAL is ambiguous. Candidates are float, long double, or double for the first argument. So you could cast this first argument here to being, double or float or something like that, and it would get rid of that. But that's really not required. You won't even see this particular complaint occurring whenever we compile this code. So I'm going to just ignore what the code analyzer is doing there. All right, so our next function is also going to return a double, and it's for calculating the volume of a sphere. So I'm going to just name the function vol a sphere, and we're also going to pass in a radius. In this particular case, we want to return 4/3 pi r cubed. So the volume of a sphere is 4/3 pi r cubed. So we'll have 4 divided by 3 times 3.159 times, use the PAL function again, r comma 3 this time. Now you notice that we use this approximation for pi here in vol of sphere and area of sphere. And if we were to go in and change this approximation, so 3.14, or maybe we do 3.141592, I think is the next position there for pi. If we were to go in and change that, we'd have to change it in both places. And maybe we have several cases in this program where we would use pi. So if you're in a situation where you're going to be using some sort of constant or representation of a value throughout your program that shouldn't change, then you should introduce what's called a constant variable. So here we'll have const as the keyword to declare a constant, and then we'll specify the type is double, and the name is pi. So we still have a type and a name, so the type is double and the name is pi. We just prefix it with this keyword constant, and that says that as soon as we've declared this and assigned a value, 3.14159, then we should not be able to assign a different value to pi anywhere else in our program. So I'm going to go in here and replace this approximation for pi with our constant that approximates pi. So we'll just put pi in both of those places. And this makes a lot more sense. It's easy to read. Oh, we're talking about 4/3, and then we have this variable called pi, and then it's being multiplied by r cubed, so 4/3 pi r cubed. Okay, the other thing we should probably note here before we move off of this vol of sphere function is we have 4 divided by 3. This is going to perform integer division, and we don't want that to occur because we lose the fractional part. So we could either make the divisor or the dividend a double value, and the way we could do that would just be adding a 0.0. So that'll make this a double. Since we have an integer divided by a double value, it will actually perform floating point division there. All right, so now I think we're ready to move on and write our main function. So int main, open paren, close paren, open brace, close brace. Now, one thing that you'll notice here is each of our function definitions is separate from the other function definitions. So none of these function definitions are inside of one another. So you don't find the function definitions inside of main. They're separate from main. Okay, so inside of main, we will just simply, declare a variable and call it radius, and we'll make use of our get pos int to get a radius for our circle and our sphere. So we'll say enter a positive integer for the radius of a circle slash sphere. Okay. So here we just called the function that we wrote, and we passed it a string value, which it expects to have a string value passed to it. All right, so now that we have that, we'll do the calculation for area of circle. So we'll say double, a circle maybe is the name of this variable that we're going to declare. And then we want to call the function area of circle. So we'll call that function and we'll pass it the radius that we just got from using getPosInt or positive int. Okay. So we're calling another function, passing in another value there. You'll notice here that the name of this variable here does not have to match our formal parameter. Those can be completely different. So you're just simply getting the radius, storing it into this variable called radius, and then we're passing a copy of the value. So if they had typed in 5 here for entering a positive integer for the radius of a circle or sphere, that 5 would have been stored in radius, and then a copy of that 5 would have been passed up here to this r. So r would receive its own copy of 5, and then it would perform the operation pi r squared. It's going to be something similar whenever we calculate the volume of the sphere. So let's do double, and then we'll call this particular variable v sphere for volume of the sphere. And then we'll call the function vol of sphere, and we'll pass it the radius. Okay. So this r here and this r here are actually two distinct r's out there in memory. So they could actually hold different values, even though we are passing the same value in both cases, because we're passing them the same value that was stored here in radius that was got from this first instruction or this first statement in the main function. Okay, we'll probably come back and clarify this and draw some diagrams of what's going on in memory, because it's important to realize, you know, what's happening in memory, where space is being allocated, what can be seen at a particular time whenever we're executing a program. So we'll get to that in some future videos. All right, so now that we have the radius, we've calculated the area of the circle, the volume of the sphere, let's go ahead and output some things to the user. So we'll do cout, insertion operator, and say the area of the circle, or of a circle that has a radius of, and use our insertion operator. Come down to the next line, use our variable called radius, and then say is, and then insertion operator, and here we'll just use a circle since that is the variable that holds our area, and then we'll use insertion operator and with a period, and then use our IO manipulator endl. Okay, and the next line is going to be very similar. So I'm going to just copy this bit of code here and paste it. So Control C is copy, Control V is paste. So here we'll say the volume, and then we'll say sphere. Oops. Sphere that has a radius of radius is, and this place will, or this will replace with v sphere. All right, so that's our basic main function. We could also add in return 0. If you don't put the return 0 again, that'll default to return 0, but some compilers may complain if you don't have that return 0 in there. All right, so that's our program 6 for the most part. So we included CMath so we could get used to the PAL function. We went in here and defined several functions. So we defined the getPosInt, area of circle, and vol of sphere. And then in the main function, we made use of those functions that we defined. So getPosInt, area of circle, and vol of sphere, volume of sphere. Okay. So let's go ahead and save this program, then we'll build it. So we're compiling and linking, and then we'll run this program. So it says enter a positive integer for the radius of a circle sphere. I'll put in 5, hit enter, and it says the area of the circle that has a radius of 5 is 78.5397, and the volume of a sphere that has a radius of 5 is 523.598. So that's our basic program, and maybe we'll come back in a later video and discuss more of it.